All right, hello Chem 116 students. We have a conversation here about alkene polymers for those who'd like to hear more instead of just reading the book or using the hints on the homework, which are certainly valid. The polymers in this chapter are all based on the ideas that they begin with alkenes. Polymers begin with small molecules that are called monomers that are combined to make a longer compound called a polymer. So many together is a polymer, one is just the monomer. And so the polymer has many identical repeating units formed by combining these little molecules. And there's oodles of biological and synthetic examples. All of our favorite plastic things like toys and plastic bottles and stuff like that are common polymers. Things like polyethylene, polypropylene, polystyrene have this ENE ending because they really do come from alkenes. And you don't need to know any of them specifically, but how they work is related to this notion of how alkenes are going to do addition reactions. In a general sense, they all begin with something that has a vinyl group where you have two carbons, and you don't have to know the name, but the two carbons that are in a double bond and some other thing, some other substituent Z is on them. You picture putting a whole bunch of these in your test tube and some magic chemical wand, I call it the initiator, is used and it allows the formation. It breaks this bond between the two carbons and allows the formation of a bond to a neighboring compound. The result is, instead of having double bonds, you end up with a bunch of single bonds between the carbons, and when it finishes, you end up with a lot of single bonds that connect the carbons that were the monomer, and periodically you have that extra group Z on them. And the polymer looks just like your monomer, except that there's got single bonds and lots of the groups tied together. In other words, all the same atoms are present in a repeating sense, but no more double bonds. So you make many polymers that from alkenes in this way. Many simple monomers and polymers can be shown. Ethylene makes polyethylene, although ethylene would be more properly known as ethene in our thinking. And propylene is also better known as propene, but those are the common names. You don't have to know their common names. You can recognize how they might be similar at least. And those are polymerized to make things that are called polypropylene and polyethylene. Polyethylene is pretty simple looking, looks like a lot of long chain hydrocarbon. Polypropylene is very similar to that, except that it's got an extra methyl group off to the side. Again, all the atoms of the monomer show up in the polymer. It's just that there's no more double bonds in them. And so the repeating unit in the polymer looks like the monomer itself, lacking the double bond. Styrene's another funny one. It's used to make styrofoam. And so the double bond breaking between those two carbons results in a backbone, as it were, of CH, alkane-like things with every other carbon attached to a benzene ring, as was shown from the styrene. So the simplest repeating fraction of this polymer looks just like your monomer, although except that it no longer has the double bond. So the polymer is much like the monomer, no longer has the double bond. Lots of units are connected. The same atoms show up in the repeating unit as are found in the monomer. So in each of these problems, the thing to do is look for the repeating unit, and then you can decide what monomer was used to get there. Well, the compound on the left, these are from your book, of course, is a compound. We don't have to know anything about its name, but the simplest repeating unit gives us a way to figure out what the monomer would be. If you're looking at this, I'm going to pick one out of the middle because I just decided to. Those atoms would become the repeating pattern, perhaps. And so you're going to have carbon with a chlorine, and you're going to have a CN, it's called a cyano group, you don't have to know its name, on that same carbon. And the other carbon is going to have CH2, but in order for this compound to be a legitimate monomer, all the carbons have to have 4 bonds. And so you put a double bond in there, and that becomes its monomer. No more to say. I did draw the geometry accurately, I just left it looking like your polymer. The one on B is similar, and if you want to pick the simplest repeating unit, I'll just pick one on the left side of the game here this time. And I didn't mean to cut off that 3, sorry. The polymer is going to be a repeating series of this repeating unit, and so you redraw the atoms of the repeating unit down here to think about what the monomer will be. And the CH2 is connected to CH, which has on it, well, and I'll put it down below for space sakes this time, CO2, which looks funny right now. It happens to be an ester. If you looked at it longer, you might be able to believe me, but right now you don't care. And CO2CH3. In order for this to be a legitimate monomer, you have to have 4 bonds on the carbons. Therefore, you put the double bond back in between those two, and that's the monomer that you need that corresponds to those polymers, in that polymer on the right. So here's another choice of looking at one. The following structure represents a segment of an alkene polymer. Identify the monomer from which the polymer was made. Think about it. And I'll give you some choices here in a second. The dark gray spheres represent carbon atoms, like those guys, all along the backbone. And the blue spheres represent hydrogen atoms, lots of them. And the white sphere in this case, or unshaded ones, are supposed to be chlorine. So you're supposed to interpret it accordingly. And now we have to decide which one would be the proper monomer to correspond with this polymer. What do you think? Well, if you look for the simplest repeating unit, the backbone is lots of carbons, and every other carbon is 2 hydrogens on it. The ones in between have chlorine and hydrogen on it. And so you could take this to be your monomer, or you could pick it a different direction and get the same idea, but left and right kind of opposite. And so the monomer has to have a double bond. Well, each of these has a double bond. That's good. And now you're looking for which option looks most like that repeating unit. The first one can't be right because it's got chlorine on both the carbons. That's not consistent with this picture. The next one, CH2CHCl. Oh, that one looks promising. Check the rest of them and make sure they're not correct. The third choice has CH2, which is fine. It looks like that part right there. But does the other carbon have 2 chlorines on it? Nope, that's not right. And so this one can't be right either. And no way can you put CH3 in here anywhere. There's no CH3 in this thing at all. So neither of those options make sense. Hope you can see that. All right, just interesting things to know. You can read in your textbook about them, the different kinds of recyclable plastics we are familiar with here and there, but lots of things recycle these days can be described as LDPE, HDPE, which are recycles numbers 2 and 4. And they're differing in only how much branching and how much cross-linking there is between them, how stiff or flexible they turn out to be. There's a whole chart of these crazy things in your textbook, of which you need to remember none. You do not have to know them. Just interesting to note that this is where things like Teflon and Lucite, maybe you've heard of it, Orlon, Acrylan, a lot of our sweaters have those things. So all of these things are alkene polymer derivatives, alkene polymer compounds. And here we go for our last one. You can always use some more humor and share these with your friends, because if you get them, then you're getting the point too. So there are examples of how you can use cis and trans in new ways. Here's another example of a polymer and a monomer. And here's another example of ortho, meta, and paradise. Happy chemistry to all of you. Good luck on your homework. Give me feedback if needed to tell me how these recordings work for you. Good luck.